Alright, so guys, today we are going to be looking at the correlation coefficient. Okay, so just before you pause the video, I will just explain what we've got on the board, then I'll give you a second to jot all it down. Okay, so the correlation coefficient, which we use the symbol R, it measures the strength of a linear relationship between two variables. Okay, so we've previously just looked at scatter plots. What we will be doing is judging, is it a strong positive linear relationship? What type is it? Okay, so as we look through by our three graphs here to give a visual demonstration, we've got no linear association. Okay, so in the first one, we can't see a linear trend. There's nothing there that stands out. It is a random set of data. Okay, the way we write that for the correlation coefficient is R equals 0. Okay, as we move through, we've got the perfect positive linear association. This is a perfect linear line and it's in a positive direction. Okay, so we give that a correlation coefficient, R value of +1. Okay, likewise with the negative, this time it's just going in a negative direction, so it gets an R value of -1. Okay, once we look at this, I think we sort of get the picture. It ranges from anywhere from -1 to +1 for our correlation coefficient. Okay, so how we judge that in terms of our linear association strength, we look at this table and this is how we judge it. Okay, so when we look at it, our strong positive, it is between 0.75 and 1. Okay, remember we are clearly looking here for the greater than or equal to signs. Okay, that's really important, especially if we get something around that 0.75, 0.5, any one of those on the fence. Okay, so I'll give you a second just to copy this side, so our graph definition and our table, and then we'll go through with the worked example. Okay. All right, so with our worked example, okay, so we've got, suppose the variance of x is 9, okay, the variance of y is 16, and the covariance of x and y is 9. Okay, find the value of R, the correlation between x and y. Okay, so what this question here is saying is pretty much it's just asking us to find the correlation coefficient. Okay, down the bottom there it just says that, and we're going to do this. How do we do this? We've got to use the formula. Okay, so I'll write the formula up in blue. This is really important, and make sure we can understand exactly what it's saying because it does have a lot of letters that can be somewhat confusing. Okay, so I'll just write this one down here. Okay, so we've got this one and it does look somewhat confusing. We haven't looked at any of these sort of variables before, but what we have got here is we've got the sample correlation between x and y as written with x, y. So I'm going to write this one down just off to the side just to help us remember what these actually are. Okay, and correlation between x and y. Okay, the next bit we've got a fraction, so we've got s subscript. These are all subscript, they're not just lowercase. So is s subscript xy is the sample covariance. Okay, so right here we've got s subscript xy is the sample covariance between x and y. Okay, the last two bits on the bottom, they are just the sample standard deviation of x and of y. Okay, so these ones are really nice and easy. We can just write s, x subscript again is the sample, and I'm just going to abbreviate here, standard deviation of x. Okay, sy subscript y again is the sample standard deviation of y. Okay, so this formula, it is quite important. It is something new, but I think it is quite straightforward, especially when we look at this worked example of how we're going to solve for it. Okay, first things first, when we look at this worked example, okay, so we've got, suppose the variance of x is 9, the variance of y is 16, and the covariance of x and y is 9. Okay, what do we know? What are we going to use? How are we going to solve this? Okay, first things first, I'm going to write down the formula. Okay, we know we're going to use this formula, so let's write it down to start our question. Okay, straight away, what do we know, what don't we know? I know a lot of you guys really like writing down your knowns and unknowns. I will do that. If you are confident, we can sub straight in, but first we've got to figure something out. Okay, so in here, it just says suppose the variance of x is 9. Okay, it doesn't say anything about the sample deviation, it's just given us the variance of x is 9. Okay, so what I'm going to do when I write that, I'm just going to do this off to the side. I'm going to write the variance of x equals 9. Okay, so how do I go from the variance of x to the sample standard deviation? All I need to do is just do a square root of that. Okay, so when I go like this, square root of 9 is 3. I get my sample standard deviation of x. Okay, I'm going to go through and I'm going to do the same thing for y. So we've got right here the variance of y is 16. So the variance of y equals 16. Therefore, my standard deviation equals 4. Okay, hopefully that one's nice and easy. All we've got to do is just find the square root to find that sample standard deviation. Now we can look at subbing into the formula. Okay, so to start with, I'm going to write what is my knowns of this formula and what don't I know. Okay, so let's look. S subscript xy, what is that? That is the sample covariance between x and y. Okay, so when I read this question, as we can see here, the covariance of x and y is 9. Okay, so right there it said the covariance between x and y is 9. Don't get too confused just because it's the same number, it doesn't mean anything. It's just saying the covariance of x and y is 9. Okay, so I can go through and I can write 9 in there. Okay, as we've done over here, I've already solved the sample standard deviation of x and y, so I can just go and sub those straight in. Okay, so I get 3 multiplied by 4, and we can just chuck that one in brackets, make it nice and easy. Okay, once we get to this step, it's just straightforward. We just chuck it in our calculator and get our answer. Okay, when I do that, or when you do that, we get 9 over 12. 3 times 4 is 12, nice and easy. Or we can just write that as a decimal, which will be 0.75. Okay, that sums it up. When we look at it now, we can look back and think, all right, we've got our correlation coefficient as 0.75. What type of linear association strength is that? Well, we've got 0.75, and this is where it's important. Our strong positive is 0.75, and it includes 0.75. Okay, so for this example, we would have a strong positive linear association strength. Okay, thank you for that. Make sure we've got all this copied down and then going through the workbook questions. Again, if you have any troubles, I know there was a bit of writing today, come see either myself or Ms. Sharp. Okay.